Review of graphs of trigonometric functions. So we need to know the sine function. Sine function has S shape. S shape and the graph looks like this. So basically speaking, what we should be able to just draw simple sine curve S shape. Simple sine curve S shape. 2 pi is right here, pi is here, and 0 is right here, and we know the value 1 and minus 1. And in the middle is pi over 2, and then we have 3 pi over 2. So that's the graph of the sine function, and it keeps going. Then we have the graph of the cosine function, and of course properties was domain is all real numbers in that case, and range is between -1 and 1. So this graph is sine x. Now we have cosine function. Cosine function. Cosine function is the V shape. Cosine function has V shape. So we need to be able to draw cos function like this as V shape. So this one here is 2 pi, in the middle is pi, the 0, pi over 2, and it keeps going on the other side, of course. So this graph is cos function. And period is, of course, 2 pi. Domain, all real numbers, range from -1 to 1, between 1 and -1. And then we have tangent function. Number 3, tangent function. Y is equal to tangent x. So the graph looks like this, has asymptotes at pi, 2 pi, 3 pi. So the graph of tangent function has asymptotes at half pi, pi over 2. Asymptote at half pi, minus pi over 2. And it's increasing graph. So in halves we have asymptote, and the graph is increasing, and the graph is increasing. That's the graph of tangent function. And of course in half we have the other asymptote. Okay, so domain is all real numbers except the asymptotes, except the halves pi, half pi, 3 half pi, and so on. And range is all real numbers. And period for tangent is nothing else but pi, because we have half pi, and half pi gives me whole pi. Period is the length that you take one part and keep repeating, you get the rest of the graph. Now we have number 4, cotangent function. Y is equal to cotangent x. Cotangent x. The asymptotes are at 0 and pi, 2 pi, 3 pi. So asymptotes of cotangent are at 0, pi, 2 pi, and 3 pi. And the cotangent graph is decreasing. And it goes pi over 2. This here would be minus pi over 2. The cotangent function is decreasing, but tangent function is increasing. So tangent function is right here. Right here it was increasing, right? Tangent function is increasing, cotangent function is decreasing. And then we have cosecant. Cosecant function. Cosecant function is built from the sine. Cosecant is 1 over sine. So we draw usually the dotted sine curve, S curve. And then we have asymptotes where was 0, asymptote where the sine curve has 0, and where was 1, we had the bump going up and down for a cosecant function. And the last one is secant graph. Secant graph is nothing else but 1 over cosine. So we start with the cosine curve. Cosine was the V shape, and then there where cosine has 0, the secant has asymptotes, and where was the 1, it goes up and goes down. So now we have example 1. Example 1. Determine the amplitude and the period of the graph. Y is equal to -3 sine 2x plus 3. Amplitude is the height of the sine, and period is the length that is repeating. So now we are starting with the sine curve. For the sine curve, original sine curve period is 2 pi, and amplitude is the height from 0 up to the 1 bump. So to determine the amplitude and period of this function, we need to, the best way is to go by the plan. How would we draw it? So number 1, I will start with sine x. Sine x, everyone knows what the sine x looks like. S shape. S shape, right? Now we can do either this multiplication or this multiplication. Multiplication of inside would be squeezing this function twice. So number 2, y is equal to sine 2x. Squeeze, vertical, horizontal compression, compress twice, 2 times. So in that case, my period has been affected, because period is from 0 to 2 pi. Now when I squeeze this, up to pi, I will have the 1 whole shape. Right? When I squeeze this, then in the other one, I will have, here is 2 pi, then that means I squeeze that function twice. So period, this time is pi. How did we get this? We can go the original period, which is 2 pi, divided by this number that we are squeezing by 2. So this cancel out, and the period is pi. Okay, then what we would do, number 3, we would multiply by this one 3 times. Y is equal to 3 sine 2x, sine 2x. So if you have 3 times, that means we expand, we stretch this graph 3 times. So in that case, the amplitude is affected, because now the graph would go bigger up to pi. This graph is extended up to 3. So amplitude is 3. Okay, it goes through 3 minus 3. We just stretch this 3 times. Number 4, I would put that minus y is equal to minus sine 3x. So minus, we just flip this over, is reflection by the x-axis. Minus is reflection by the x-axis, does not change amplitude, neither period. And plus 3, then we have plus 3, that means we would move up by 3. That does not affect the amplitude, neither amplitude nor period. So that's what we have. So my period is pi, and my amplitude is 3. Now we need to remember, once talking about trigonometric functions, we need to remember to factor. Remember to factor when graphing the function like this. We need to factor this because the phase shift or horizontal shift is not pi. It's gonna be, once we factor, it's gonna be different. So we have sine, we factor 3 out, so x is x left, and this we need to pi divided by 3. So this one is the compression, but that's the phase shift or horizontal shift. Phase shift, or in other words, we move it, the graph, horizontally by pi over 3. That's very important, by pi over 3, not by pi. In that case, we are moving to the right. We are moving to the right because it's minus. We are moving to the right by pi over 3. Okay, so this one we are moving to the right pi over 3, to be clear. Now we have example 2. Find the amplitude, period, phase shift, and graph the function. And we have y is equal to 3 cos 2x minus pi over 2. So first thing, we need to factor this 2 out. First thing, we need to factor this 2 out. 3 cos, take the 2 out, x minus, and then what we have, we divide by 2. We divide by 2. So I have pi over 2 divided by 2. Pi over 2 divided by 2 is like 2 over 1. That means I need to flip it over. Pi over 2 times 1/2. So in that case, I'm getting that this one is pi over 4. 1 times 2. So we have pi over 4, and that's it. So we need to make the plan to graph this function. Number 1, y is equal to cos x. The graph of the cos function has the v shape. 2 pi, and here is pi. Now we can either squeeze it twice, 2, so number 2, we're gonna graph y is equal to cos 2x. So then compress twice. Compress twice. Twice. 2 times. So my graph will be now within 1 pi. Here's my pi, here is my 2 pi. Within 1 pi, I need to have the V shape. Within 1 pi, I have the V shape. That means compress. Okay, and then within the other, I would have the other V shape. And then we don't subtract, because first is multiplication. So first we need to multiply. So number 3 is y is equal to 3 cos 2x. That means expand vertically. That means expand vertically. So this graph is gonna be going from 1 to up to 3. This part stays 1, 2, 3, 1, 2, 3, and it goes like this. Expand, and goes up to 0, and up to 3, up to 0, and up to 3, up to 0, and up to 3. Okay, so this graph is 3 cos 2x. And the last thing what we need to do, we need to move that graph, number 4, y is equal to 3 cos, now we have 2x minus pi over 4. We need to move the graph pi over 4 to the right. So here's my pi, in the middle pi over 2, and half of that pi over 4. So the graph is moved pi over 4 units to the right. So my 0 is gonna be at half pi. This is my x-axis is gonna be shifted. So the graph starts from here, goes right here, then the 1 is gonna be right here, and then the 0 is gonna be right here, and the 1 is moved to the right, and the 0 is moved to the right, and the 1 minus 3 actually is moved to the right, and this one is moved to the right, and this one is moved to the right. Here we go. So the red graph is my final answer. Example 3. Write the equation of a sine function with amplitude 5, period pi over 4, and the phase shift minus 2 pi. So amplitude 5 pi, we start y is equal to sine x. To get the amplitude 5 pi, 5, not pi, 5, that means the graph was stretched 5 times. So then we had the 5 in front, sine x. Now we would like to have the period. Period is pi over 4. So in general, y is equal to sine, and we can have some number kx. Then the period of this function is 2 pi over k. Okay, so now we can substitute to this equation. My period is pi over 4. I'm looking for that factor what to multiply, so I have 2 pi over k. Okay, so I can cross multiply. I have pi k is equal to 8 pi, divide by pi. So my k is equal to 8. My k is equal to 8. So the graph is right here. So we'll have y is equal to 5 sine 8 times x. That means the graph was compressed 8 times. And then we have the phase shift. Remember that the phase shift, as before, the phase shift is not here. The phase shift, the number needs to go outside, then we have the phase shift. So for my graph, we have y is equal to 5 sine 8 goes out, and then we have x minus pi over 2. That means phase shift to the left. So it's minus plus 2 pi. That's my graph that has amplitude 5, period pi over 4, and the phase shift negative 2 pi, or 2 pi to the left.